This is Daniel Coosbury, and in this lecture we're going to be looking at weight and temperature. So we'll start with weight, and the weight you'll find is going to work very similarly to how we did problems with length and problems with volume. And so we'll start out with the metric system, and what I've done is I've kind of set up a little mnemonic down here like we did with length. The weight in the metric system is used in grams, and so we got the same prefixes as we did with meters. We got kilograms, hectograms, and so on. And the nice thing is the conversions are going to work exactly the same in the metric system. So I'm just going to go ahead and do this and show you the mnemonic again. If I want to convert 12.9 hectograms to grams, I'm going to imagine starting out at hectograms, and I'm going to end up moving the decimal 2 places to get to grams. That's how this mnemonic works. Is if you order these, I guess, prefixes or these units in the order from greatest to smallest, then going from one unit to another amounts to moving the decimal that many spaces in that direction. So here I'm moving 2 to the right, which means I'm moving the decimal here to the right, which means that 12.9 hectograms is equal to 1,290 grams. I move the decimal to the right, and I end up with that. So the same thing happens with this one. I'm going from milligrams to decagrams. So I'm imagining starting way back here, and I'm moving the decimal 4 places to the left. So here in this number, I'm moving it 4 places to the left, and that means that 1,420 milligrams is equal to 0.142 decagrams. DAG. So honestly, metric system is really nice because converting units just works really well every single time. So you can use that mnemonic as much as you want. You can use it with grams, you can use it with meters, you can also use it with liters. I don't think I showed you that, but it works the same if you were to do kiloliters and liters and all that. Everything kind of works the same. All right, this example wants us to convert the volume of water, or it gives us the volume of water in an aquarium, and it asks us how much it weighs. And I want to show you this because there's a little part of your formula sheet that looks like this, except it doesn't have my words up here. But as 1 cubic centimeter is equal to 1 milliliter, which is equal to 1 gram. And now we can talk about weight. Now, I wanted to point this out because this part of the formula sheet only has to do with water. In other words, it tells you that 1 cubic centimeter of water, a certain volume of water, weighs 1 gram. And the reason it's important to note this has to do with water is because a cubic centimeter of any substance doesn't necessarily have the same weight. Like a cubic centimeter of lead is going to be a lot heavier than 1 gram. But with water, this holds. So we have a few different things that relate volume to weight of water. So we can't just use these for any substance because all the substance kind of weigh different things and take up different space. They're different densities and so on. But we can use it for water. So with that being said, I want to show you, let's see. I guess we can use any of these. I guess we can use this one right here. We got cubic meters, and we want to go to maybe kilograms. Why don't we go to kilograms? So we'll do 0.145 cubic meters, and then I want to multiply it by a unit fraction. That fraction is going to have 1 cubic meter in the denominator and 1,000 kilograms. So that's going to cancel. And that just means I'm going to multiply that by 1,000, which means I move the decimal over 3 places. I get 145 kilograms. So that's how we do that. So I just wanted to point out that little part of your formula sheet. We could also write that in terms of tons if you wanted to. That's tons spelled T-O-N-N-E-S, which is not the typical tons that you're used to. I think I'm going to show you a little bit more. But this is the metric tons, which is just spelled in a weird British way if you want. But we could have converted that into tons, which is represented by a little t if we wanted to. But I didn't want to. I wanted to do kilograms. It didn't specify. That being said, here's a problem about tons. So this is our American version of tons. This is our tons. That's 2,000 pounds. And this is the metric version of tons, which is equal to 1,000 kilograms. So the difference is the American tons is represented with a capital T. You've probably seen that a lot, whereas you may have never seen the lowercase t representing the metric tons. But anyway, we have a conversion for that, and now that I've beat that dead horse, you can use that conversion just like you use any of these other unit conversions. I'm going to go 3 tons times a unit fraction with 1 ton in the denominator and 0.9 tons, little t tons, in the numerator. So now my big t's cancel out. My little t remains. I'm doing 3 times 0.9. I end up with 2.7 little t tons. So anyway, I just wanted to make you aware of that. It's kind of a weird unit. I can't say I use it very much, but there it is. And then I want to do 12 kilograms to pounds, and it looks like I can do that just as easily with this next unit fraction, or the conversion here. I'll turn it into a unit fraction. So I'm going to go kilograms and pounds. Kilograms goes down here. That's 0.45. And 1 pound goes up here. That cancels. I'm doing 12 divided by 0.45, which gives me 26.666666 pounds, which works like that. So there's dimensional analysis. Hasn't changed. Works the same. It's kind of nice. Okay, here's a little bit more challenging problem. I thought it might be worth doing. Really practical. So we have a prescribed dosage of a drug is 10 milligrams per kilogram daily, meaning that 10 milligrams of the drug should be administered daily for each kilogram of a person's weight. So that's kind of what that means. Is for every kilogram you weigh, you got to take 10 milligrams of this drug. It changes based on body weight. How many 400 milligram tablets should be given each day to a patient weighing 175 pounds? So what we need to do is we need to figure out how much drug that this person who weighs this much needs, and then how many tablets should they take of this drug. So it's a real practical thing if you're in the process of either prescribing drugs or if you work at a pharmacy and you got give them the right amount, something you might encounter terribly often. So let's say the first thing we do is everything in this problem is talking about milligrams and kilograms. So let's start by changing this to kilograms, because maybe that'll give us kind of a way to go forward. I want to go from pounds to kilograms, and I think I just did that, but I'll do it again. That goes on the top this time. I need pounds to go in the bottom. So 1 pound is equal to 0.45 kilograms. So that cancels. I'm doing multiplication this time. 175 times 0.45 is equal to 78.75 kilograms. Now, now that I have it in kilograms, I can look back up at this first sentence that says 10 milligrams should be administered every day per kilogram of weight. So I'm actually going to kind of think of this in terms of a unit fraction. That is, for every kilogram of weight I have, I need 10 milligrams of drug, whatever it is. So I'm going to actually think of this as a unit fraction just to show you kind of how this works. We're going to do 10 milligrams of drug, whatever that is, drug, per 1 kilogram of weight. So I'm doing what sort of looks like another unit conversion, but all I'm doing is actually taking this 10 milligrams per kilogram and turning it into something that we're used to working with. So milligrams over kilograms. This way, my kilograms of weight cancels out, and I just have milligrams of drug. That's going to tell me how much drug I need. So I'm going to do 78.75 times 10, which gives me 787.5 milligrams of drug, which I'm not going to write the of drug part. That tells me how much of the drug this person needs to take daily. I'm almost done. So the very last question says, how many 400 milligram tablets should they take? Now I have the total amount of the drug they need every day. I want to now convert that into 400 milligram tablets. So imagine dividing this number by 400 to see how many tablets we need. So I'm just going to do that division real quick. 787, that's my total amount. I'll divide it by 400, and I'll end up with almost two tablets, but I can give you the exact number, 1.97 and some change tablets per day. So I don't know how concentrated this is. If you want to round it up to 2 tablets, you're a pharmacist, you know what you're doing, you can do that. But anyway, this is a little more precise. This is how many tablets that person needs to take a day, almost 2. If it's not that big of a deal, maybe just take 2 tablets a day. But hey, there's a fun problem. We just did a few different conversions. We did a unit conversion. We did something that felt like a unit conversion, but really just used the information here, milligrams over kilograms. We did milligrams over kilograms, and then we converted it into tablets, which is kind of fun. So really useful stuff, really practical stuff if you're in pharmacy at least. So that's kind of fun. Okay, the second part of this section is not too terrible because we're going to be converting for the 2 main units of temperature. And there's these 2 formulas that basically go from one to the other. So what we're going to do is we're just going to do one example with each of these formulas. And to be honest, all these problems pretty much work their way out the same way. You're either using this one or using that one. So let's convert 50 degrees Celsius to Fahrenheit. We're going to use this formula. The way to read this is when you see F, that's the degrees Fahrenheit. When you see C, that's the degrees Celsius. So when I have the degrees Celsius, I'm going to plug that in for C. I don't have degrees Fahrenheit, so I'm just going to leave that as F. If I don't have it, that's going to be a variable. It's going to be just a letter. If I do have it, I'm going to replace that letter with the number that I have. So F is equal to 9/5 times 50 degrees Celsius plus 32. So it's not too bad. Now I just need to simplify that right side. So you can do this however you want. You can put it in your calculator, or you can kind of work it out in your hands. I'm going to do 50 divided by 5 here, make it 10. So 9 times 10 plus 32, or 90 plus 32, or 122 degrees Fahrenheit. Or you could have stuck all this in your calculator. You just got to do it carefully so that nothing goes wrong. But that's all that is using that formula. Going from Fahrenheit to Celsius is also as simple as using a formula, but you have to use the other one. So here I have 59 degrees Fahrenheit. That's going to get plugged in for F. And since I don't know what degrees Celsius it is, I'm going to leave that C as C. So I'll rewrite the formula then as 5/9. And notice this has a parentheses here. 59 minus 32. And then I'll just simplify that side. So again, there's a kind of a noticeable difference in this formula is this one has parentheses around some things. The last one didn't. So if you're trying to kind of keep it straight, it really does make a difference what formula it is. But the parentheses matter. If you do this in your calculator, you got to make sure you include them, because this means I'm going to subtract first and then multiply by 5/9. Without the parentheses, I think I did the multiplication first and then I added 32. It's a kind of an order of operations thing. But anyway, I'm going to do this. Do the subtraction first. 59 minus 32 is equal to 27. And then maybe I'll do 27 divided by 9 to get 5 times 3, which is equal to 15 degrees Celsius. Or you could do all that in your calculator and get 15 degrees Celsius. So that's how that works. Temperature conversion is really not too bad. The biggest thing is remembering which formula is which. So the way you could either, you probably won't have these sort of headings ahead of you if they are for you when you take a quiz or something. But if you did, that'd be nice. But the way I remember it is whatever number I have, I'm going to plug in for that letter, and whatever number I don't have, I'm going to leave that letter blank, and then I can use whichever formula works.